In this video, you will learn how to calculate the surface area and volume of a pyramid. A pyramid is a polyhedron in which one face, the base, it can be a polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex. Typically, the base will be a square for our videos, however, it could technically be any shape. And you name a pyramid by the base of its shape. If the pyramid has a regular polygon as the base, then it is what we call a regular pyramid, and the lateral faces are all congruent isosceles triangles. The height of the figure is still the height from the apex to the base, so this is our height here, versus a new term, the slant height is the height of the side or the lateral face of the pyramid. So this is what we call our slant height. In order to calculate the lateral area and the surface area, the lateral area, if we look, it says that the lateral area and surface area of the pyramid is the concept that we have been working with, just adding the areas of the faces. When we find the area of the lateral faces, it's important to look at the shape of the base. Now, in terms of calculating the lateral area, if we think about it, the lateral area is all just a bunch of triangles. And again, typically ours is going to be a regular pyramid, so they'll all be the same. So we can really calculate the lateral area is the number of triangles times the area of one triangle. So as we discussed before, the lateral area equals the number of triangles times the area of one triangle. And if I'm putting this all together, we know now that the surface area is going to equal the lateral area plus the key difference here is now in prisms and cylinders there's two bases. However, a pyramid only has one. So it's the lateral area plus one base. As we discussed in the warm-up introducing this concept, the formula for the volume is similar. However, if I were to calculate the volume, if I did the area of the base times the height, it would be calculating the area of a prism. So to account for the missing parts of that prism, our formula is it's 1/3 the area of the base times the height. So the B is the area of the base, and the H is the height of the figure, which in our case would be this vertical dotted line. Our next problem asks us to calculate the lateral area, surface area, and volume of the pyramid. So if we first focus on the base is, and it's assuming it's a regular pyramid, so it's a square base where all the sides are 7.5. So if I find the area of the base, it would be 7.5 times 7.5, which gives us a value of 56.25 feet squared. Now for the lateral area is, again, those lateral faces, and they're all triangles for a pyramid. So if I redraw my triangle, I have this side length is 7.5, and the height of the triangle is 12. So the area of one triangle, for this example, would be 1/2 times 7.5 times 12. So the area of the triangle, if we plug that in, is 45. And now if I'm putting this together for the lateral area equals the number of triangles times the area of one triangle. So in this case, lateral area equals our number of triangles is 4 times the area of one triangle is 45. And if I plug that in, 45 times 4, you get your lateral area equals 180 feet squared. So this is one part of our answer to the problem. Now if I'm calculating the surface area, as we said before, surface area for a pyramid is lateral area plus the area of one base. So there's only one base in our pyramid. So for this case, surface area equals our lateral area, which is 180, plus the area of the base is 56.25. So when you plug that in, you get your surface area equals 236.25 feet squared. Now the last part of this problem asks you to calculate the volume. Now in order to calculate the volume, it's 1/3 the area of the base times the height. Now if I substitute, I have that the volume equals 1/3 the area of the base we already calculated is 56.25. However, the height we don't have yet because the height is this vertical distance. Now, using the fact that it's 7.5 all the way across, if I do 7.5 and I divide it in half, we get a value of 3.75, which tells us that each of these smaller sections are 3.75. And now if I focus on just what we're given in this triangle, so if I focus on this part, I now have a right triangle with the height, the 12, and the 3.75. So if I redraw my triangle, I have that this is the height, this is 12, and this is 3.75. So if I use Pythagorean theorem, I have h squared plus 3.75 squared equals 12 squared. When I solve, 12 squared minus 3.75 squared gives me that this is 129.9375. And when you take the square root of both sides, you're going to get a decimal. But if I round my decimal to the nearest hundredth, I get it equals 11.4. So now if I go to substitute into my formula, I have that the volume equals 1/3 times 56.25 times 11.4. And when you plug that in, it's 1/3 times 56.25 times 11.4 gives you a value of 213.75, and again our units is feet cubed. In our next example, it again asks us to find the lateral area, surface area, and volume of the pyramid. If we first identify the base is a square that is 11 by 11. So the area of the base would be 121 miles squared. The lateral area is the 4 triangles, so it's 4 times each of the lateral faces. You know that the base of each of these lateral faces, if I highlight one of them, I can tell looking at it that the base of this face has a length of 11. So I know that this length is 11. However, I don't know what this height is. But if I look at my diagram and I draw in the height of these lateral faces, this is what we call our slant height. And now if I complete my right triangle, we know that this distance all the way across is 11. So if I do 11 divided by 2, gives you 5.5, telling us that each of these parts of this distance across has a length of 5.5. So now I have a right triangle right here with this side length of L, this side is 12, and this side is 5.5. So if I need to find that height, or the slant height, I can use this is 5.5, this is 12, and this is L. So if I use Pythagorean theorem, because it's a right triangle, I can say 12 squared plus 5.5 squared equals L squared. If I add 12 squared plus 5.5 squared, it gives you 174.25 equals L squared. So if you take the square root of both sides, you get a value of 13.2 equals L. So now this side is 13.2. So if I want to find the area of one of the triangles, it's 1/2 times 11 times 13.2. So I get the area of the triangle would be 72.6. So our lateral area is 4 times the 72.6 because there's 4 faces. We get that the lateral area is 290.4 miles squared, giving us the first part of our answer. Now the surface area equals the lateral area plus 1 base. So our surface area equals the lateral area, which is 290.4, plus the area of one of the bases is 121. So we get our final answer is 411.4 miles squared is our surface area. Now the final calculation it asks us to complete is it asks for the volume. So our volume equals 1/3 the area of the base times the height. So in this case, the volume is 1/3 times the area of the base is 121 times the height is the distance from the apex of the pyramid to the base, which in this case is 12. So it'll be 121 times 12, and if you plug that in, we have 1/3 times 121 times 12 gives you an answer of 484 miles cubed.